This is the class lesson for section 3.7, part 2 of inverse functions. And we're going to begin in number 1 with deciding whether each function defines a one-to-one function. And if so, we will find the equation of the inverse. So, starting with number 1a, we note that we have the absolute value function. And that is the shape of a graph. It has the shape of a V. We've talked about that several times. 1, 1, negative 1, 1. Here you can see that we have repeated y values. Also, we can see that the graph fails the horizontal line test. So several ways to show that f of x equals the absolute value of x is not a one-to-one function. So fails the horizontal line test or repeated coordinates. Okay, so we can't find an inverse, and that might even be nice to make a statement. Therefore, f inverse does not exist. Okay, let's look at B. What do you notice? This is a linear function. So this is a one-to-one function since linear. Okay, let's go ahead and go to C, x cubed plus 5. Taking a look at this is our cubing function, cubic either way. And it is shifted up 5 units. It just looks like that. I'll maybe get rid of that tick mark, make that there. So as you can see clearly, this passes the horizontal line test. I also want to mention, take a look at how the y values are generated with this function. You input an x value, cube it, and add 5 to it. So every x value will have a unique y value. So that's also an indication that h of x is one-to-one. Okay? So we do need to find the equations of these inverses in B and C, so we will do that here shortly. Let's go ahead and look at D. So looking at D, we have that this is a rational expression, and I will tell you that it is one-to-one, and usually students will graph to verify one-to-one. And we're actually going to start here. So let's go ahead and go through our steps, and then we'll go back to both B and C, where we will find the inverses of those functions. Okay? So let's go ahead and begin here. We're going to let f of x equal y. Then we're going to interchange x and y. So everywhere there's an x, we're going to write a y, and everywhere there's a y, we're going to write an x. We're going to multiply both sides of the equation by y minus 5. So on the left-hand side, we're going to distribute that x, so we'll have xy minus 5x equals, and if you notice here, that's why we did this, we have negative 3y plus 1. Now we need to solve for y because that is one of the steps. So as you can notice, I have a term with a y in it and a term with a y in it here. I need them on the same side of the equation. So I'm going to add 3y to both sides, and guess what? I'm going to subtract add 5x to both sides. So there were 2 steps in there. I added 5x and I added 3y. Okay? So now we have the terms that have a y in them so that we could factor out that y. And now let's see what we have. Y equals 1 plus 5x divided by x plus 3. So I'm dividing both sides by x plus 3. And now this result is what we call F inverse of x. Okay. Now, let's go back to B. We decided that this was a one-to-one function, so G inverse exists. So how we're going to find that is we're going to let G of x be y. We're going to interchange our x and our y values. And now we're going to solve for y. I will add 7 to both sides. And now I will solve for y by dividing both sides by 4. And now we can call that G inverse of x. Okay. We'll go down to C here and see if we can come up with an inverse function for h of x. So let me give myself some room here. And we're going to go ahead, maybe I'll write in a little bit different color, so if I end up going over there, I won't run into it. We're going to start with y equals x cubed plus 5. We're going to interchange or replace x with y and y with x. Now I'm going to subtract 5 from both sides. And I'm going to take the cube root of both sides. So I have the cube root of x minus 5 equals the cube root of y cubed. And you can see that y is the cube root of x minus 5. So now we can say h inverse of x is equal to the cube root of x minus 5. Okay, let's go to number 2. Determine whether the functions f and g graphed are inverses of each other. Well, first of all, this line y equal to x is supposed to be a mirror image. And as you can see, these two graphs are not mirror images of each other across that line y equal to x. So I will just show you that if you had used this graph and you wanted to reflect it, it would be about like that, the mirror image. So this is definitely not two inverses graphed together. So f and g are not inverses of each other. Okay, so let's go ahead and look over here. This is a great example. As you can see, this graph and this graph, they are mirror images of each other. And a little further down the graph, both parts of that are. So you can also check some points. We might want to check, let's go ahead and check this point. That point right there is 2, let's call it 1.5. So 1.5, 2 must be on this graph, and it is. The inverse. So f and g are inverses of each other. Okay, and now let's go ahead and look at this last problem, x plus 4, and talk about some restrictions. So find the inverse of the function with a restricted domain. So as you know, this graph, x squared plus 4, is the squaring function shifted up 4 units, and it fails the horizontal line test. So what they've told us is we want to find the inverse of this function, but on this restricted domain. And that domain is going to be where x is less than or equal to 0. So I'm going to put here no restrictions. But now let's sketch this graph with in fact, let me draw it like that. And that would look just like that graph. Okay, that is where x is less than or equal to 0. And this is restricted domain, negative infinity to 0. Okay, so let's go ahead and find that. We're going to first let f of x be y. Then we're going to interchange x and y. And now we're going to solve for y. We end up with plus or minus the square root of x minus 4. Now, there's a couple of ways you can figure this out. If f is restricted with x less than or equal to 0, since they interchange their domain and range, the y values will have to be less than or equal to 0 on f inverse. It's seen a little bit better over here. So let me go ahead and sketch this. Okay, and now we'll go ahead and draw the inverse function. So if this point is 0, 4, we are going to be at 4, 0. Okay, and that graph will come around a little bit, and we could try some points, but it will come around and look something like that. Okay, and like I said, you can try a few different points. But the important thing to note is that, and that graph, in fact, let me just put that 4, 0 somewhere else so you can get a better view. It'll look something like that. And this is 4, 0. So we just did a mirror image across the line y equal to x. And now we know we do not want any positive y values. This says y is the positive root and y is the negative root. And we want to take these, and we don't want those y values. Okay? So with a restricted domain. So now we want to go ahead and use the inverse as this one with the negative y values. Therefore, f inverse of x is equal to the opposite of the square root of x minus 4.